Okay, you're welcome to start, Nai.
This is our short presentation. Hi, my name is Nai Alharbi. In this presentation, I'm going to briefly describe our work, and if we got some time, I'm going to play a video to demonstrate our results. We are working on membrane simulation dataset. The dataset represents the dynamics of two types of molecules, protein and lipids. The dynamics of these molecules cause interactions between protein and lipids molecule or their particles. Studying this interaction helps scientists to understand the behavior of the molecules in the membranes. Actually, the dataset is nothing but the position of each particles over the time, so it needs to be represented in some way. And the common way to represent the molecules is using the simple spheres, as you see in the first image, or another way that can be represented by a complex surfaces. If you have a close look to the simulation data, this is a snapshot of one time step. You maybe couldn't get insight into the protein-like interaction. This is the protein, and the surrounding is the lipid particles. This is the motivation of our work. If we think, on the other hand, to use the complex surfaces to visualize the protein, it might be quite expensive to do. We contribute propose by proposing our abstract protein to be halfway between the complexity of the surfaces and the simplicity of the van der Waals sphere. Also, we contribute by implementing the projection of the interaction on the surface of the cylinder on the GPU. Here you can see the description of our simulation data. In short, it's more than 300,000 particles. They interact or move in the membranes over 2,000 nanoseconds, which worth 8 gigabytes of memory. Here the structure of the molecules. This one is the protein structure, which include a cloud of points or spheres, and these are the structure of the lips. They deform over the time when they move in the system. Our solution or design, we use the principal component analysis method to construct the local space of each protein by finding the eigen and the eigenvectors and the value to construct the height and the width of the cylinder. Here you can see the membranes. The green particles represent the lipids, and the yellow body is the protein molecule. The protein, if you replace it by our cylinder, then you will see the wall of the protein will encode the interaction. When the flow of the molecule surrounding the protein move, it will interact with the wall of the cylinder. This way, as you can see, it's much simpler than the traditional surfaces representation. How do our solution enhance the performance? We use two tests. The first test, when any particle cross the boundary of the protein, of a protein, we can catch that particle and consider it's likely to have an interaction with the particles of the protein bodies. Then we go forward and test the distance between this particle against all the particles of the protein in question. Also, as you can see, the enhancement in the perception using our method. This is the simple way to represent the protein-lipid interaction, and this is our result. This video shows our results. This is the protein-lipid interaction using Naif approach. Even when you go and see the close view, still difficult to get insight into the interaction. Now we use our abstract protein space. There is variety of options to be used with the representation. You can use focus and context to get insight into the protein-lipid interaction and see the particles in context. Also here you can see the interaction when some particles hit the surface of the abstract space. Okay, the result of this work can be used in our future work by projecting the surface of the protein from the 3D into 2D for more analysis work. Thank you. Any questions?
What's colour mapped to on your cylinders? You have the colour displays on them. What are they actually mapped to?
It maps to the frequency of the interaction. If some particle interact with that tile of the cylinder, it will increase based on the number of interaction.
But it doesn't change in the animation at all. It is static, so it's over the whole animation. As it were, it's like number of interactions over the whole time period.
Yeah.
So
it will increase based on the interaction. Maybe in our case, there is no variety of the number, so you couldn't see the change.
Okay.
Maybe that's the reason.
Yeah.
It is updated dynamically. yeah, over time.
So the actual glyph itself, it removes the protein inside it. So the interactions between it and the protein can't be seen. So have you found anything interesting with the lipids interacting with each other, or?
Yeah, it's another direction to be studied when you try to test the lipid against the lipid. But our focus now is in the lipid protein and protein interaction.
Okay.
Yeah, but it's a good idea to think about.
Do you have a filter option where you can filter out, or like take the naive approach and then filter everything outside of the circles so that you can only have essentially the proteins visualized along with the lipids that are close to them? Is that an option at all? Or?
Yeah, it's a great idea. It's in our future work. We have done it.
I don't remember the name of the technique, but have you ever tried to map the opacity, for example, to focus on the important part instead of making everything opaque?
Yeah, also it's a good idea. We are going to use it. Yes.
Because I don't remember the name, but I remember they use it with the path lines, where you have like very dense path lines, so I think it's focus.
Focus in context.
This is a more
Economic focus.
I think something like that. So it's only showing like the structure, and the rest of the path lines is transparent to make you able to see the structure, the main structure of the path lines. But I think it might be useful to have the same focus, but on the protein, and like making everything else less opaque.
So it's like a temporal distance, focus and context. So as it's closer to the current time step, that would at least use and then it's
Yeah.
I don't know, I was trying to think of a name for it. But,
He does have a user option that lets the user adjust the opacity
Is it?
of the context.
Yeah.
Yes. Well, you used to. At one point, he definitely had it.
Yeah.
Okay, what about error, Nai? Like, how much error do you think is encoded in your cylinders?
Yeah, actually, we haven't calculated the one mean square of the errors, so actually I have no idea. It might be, I guess it should be very small.
Mm-hmm.
Yeah, should be very small.
So here's an answer to remember. Try to remember this. You can give two answers. You can say which error do you, well, you can also ask which error do you mean? Like, can you be more specific in terms of which error do you mean? That's the first option. The second option is we haven't studied the error analysis in detail. That's an area of future research. The third answer is, and I'd also like you to mention this, the user can always turn on the original molecule, the original molecular surface, and watch the interaction, the original lipid protein interaction. Like that's doesn't include the cylinder, or could include the cylinder, but the user always has the option to turn on the original proteins to see the exact distances and more detail on the interaction. So try to remember those, because that question is very, very likely. Maybe nobody will ask it because the time will run out, but that is a very, very likely question, I would say.
Yeah, thank you, Bob. Actually, I thought the error maybe could be the distance test and the rotation. That's what always might be made the error in our case.
Yeah.
For the distance, I'm quite sure it's correct. But the rotation, if there is something wrong, maybe the rotation.
Okay.
There is some-
Yeah, yeah. That's going to be a question during your Viva as well, by the way.
Thank you.
A very related question. Which application did you use to record the videos?
Camtasia.
Camtasia?
Camtasia.
It's not necessary, though. He could use iMovie or QuickTime.
Yeah, I know, but I feel it's much more user-friendly.
Camtasia?
Yeah,
Okay.
but you need to pay.
I use OBS Studio. OBS Studio is pretty great.
What is it?
OBS Studio.
I've never heard of that one.
Open Broadcaster,
Yeah.
that's the one.
Okay. Yeah, you've used that one, haven't you?
And you use it
I also use it, but I don't know, somehow it's not, resolution is not high on my machine, but maybe I could have.
You should be able to change the settings.
Yeah, you can just put it in HD.
Recorded raw footage for the my study and those,
What?
like,
No, thanks.
Somebody's gonna save me from myself then.
So your timing was very good. You lasted 9 minutes, which is good. I would also recommend modifying the way you say lipid. Like when you say lipid, it sounds like one cylinder.
Yeah.
Sorry, syllable. But it's 2 syllables, lipid. Like, yeah.
Lipid.
Lipid, yeah.
I thought you were saying, what were you saying before?
Lips.
Lipped, yeah. You can say lipids, that's 2 syllables. Lipids is what I would usually say.
Lipids. Okay.
Yeah, I always said lipids.
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 Like,
A lot of those things like fungi and fungi and fungi. Yeah, you can pronounce it in 4 different ways if you check on the dictionary. Yeah.
I would also be tempted to show a visualization result just like as a preview right after the naive approach. So you have a slide right in the beginning that talks about the naive solution.
Yeah.
And I would be very tempted to show just a preview of our solution right after this. Like, here's what you could be, like this naive scene could be replaced by this, and you show your nice tiled cylinders, you know. And I would also, near the beginning, somehow mention that this is a membrane simulation that consists of proteins and lipids.
Okay.
You did mention it later on,
Yeah.
but I think I would mention it early on, somewhere. Okay, yeah, there it is, membrane simulation. It's singular, by the way, singular membrane.
Thank you. I'll do it later. Okay.
Nai, do you know if you're going to have 16 by 9 monitors? You designed your presentation in
Yeah.
16 by 9, and it's just if it's not 16 by 9, everything will shrink, which is usually why I think it's 4 by 3.
Yeah, thank you. Actually, I follow the advice by the conference organizer.
So
They
probably
say,
do have
yeah.
16 by 9. Okay.
You got something funny going on with the numbers, 1 and 2,
Right, yeah.
and all of them are a bit off as well.
Yeah, thank you. I think it's, yeah, it's wrong.
If you are using 16 by 9, the last slide will start as well.
Yeah, I should do know.
What's the 1 and 2?
Oh, the side numbers. You've got 1 and 2 in the same
Slide
one.
1, 2,
Oh, I see.
at the same time.
I see.
And then you go through them, they kind of change a bit. You want to change them too.
This one, 2, 3. Yeah.
That's my fault.
Okay.
Because the template I have. I've never been able to figure out the slide numbers properly.
I think it was correct, but when I moved to the new,
61.
yeah, it's give me the new numbers.
PowerPoint slide number is still an unsolved problem.
Maybe for slide 2, I think just change the image. Yeah,
This one.
Image to fit it inside the-
Thank you.
So you ask all the students to have the same template?
Excuse me?
Do you ask all the students to have the same template?
No, I don't. They can use whatever, you guys can use whatever you want, but I say you can use this.
I only use it because I had to follow your slides for
Mhm.
the SOS.
Mhm.
So I just use that in the sense.
I like it very simple. Yes.
It's a problem.
There are some groups that are very good at creating templates and they all use the same template.
Yeah, it's a good idea.
I can't be bothered. It's just,
If we tackle PowerPoint first.
yeah, I just can't. I don't have that level of, I don't know, PowerPoint drive. Okay, in your contribution slide, I think you have a contribution slide.
Yeah.
Yeah. I would say, I would add a contribution, and that it would be the first one. I would say this is the first surface of its kind to focus on interaction space specifically. That is like the one sentence idea that started this whole project. And that is followed by something like traditional surfaces are particle based or particle centered. They're focused on molecules and atoms. This is the first one that's focused on the space between the atoms and the molecules. And that's the thing that's novel. Like that's conceptually the part that is novel. It's a different focus.
Right.
It's not focusing on a molecular surface or particle surface like all of the other literature, actually. This is the first interaction surface. You know, that would be a great thing to mention.
On this slide, I think you can make the image bigger and just have the text wrap.
Okay.
on
That's
that
true,
side.
yeah.
I think that would be nicer.
That's true. Yep. Also, in your video, you have a lot of time to add some commentary. So when you're showing your video, I would mention the benefits of your approach. You say, here it is, but you don't say, oh, look at what it's good for. You say, notice how these surfaces reduce occlusion, they reduce visual complexity. Now we can actually see the interaction between the lipids and the proteins, whereas before we couldn't.
Right.
And then you would mention the tiling. So I don't think you mentioned the tiles at all.
Yeah.
And the color mapped tiles, which is what Dylan was asking about.
Maybe keep it for the questions.
Well, I noticed you had plenty of room in the video. There was lots of silence during the video where he could have been adding these comments.
Yeah, but I think if he answer all the questions during the presentation, then he leaves the space for the hard questions.
It's only a short
Yeah.
question span though, isn't it? So you probably get away with it.
If you ask a hard question, sorry, we're out of time. Next time.
You still have 2 minutes questions now.
There's probably going to be time for one, maximum 2 questions, maximum.
Just remember to drag out the first question.
What was the question again?
Oh yeah, can you repeat the question?
Oh, I haven't
All
thought.
right.
All
But yeah.
techniques.
The session chair has to be really, really like, boom, time is over, if he wants the thing to go to schedule. Because a lot of people will go longer, they will try to go longer. The context switches always take more time than everybody imagines.
Yeah, any idea how many are doing talking during your session?
None.
9? Oh wow.
That's a lot, yeah.
Yeah.
For 2 hours session.
So 100 minutes.
I have something. Do you get time?
Time is up.
All right. So what was your motivation to work on this topic, and what is energy simulation as well?
Actually, the motivation was at the beginning of my PhD. I had to choose a topic. I like scientific things, and that was the one I think that passed at the time. And the simulation is it's a molecular dynamic simulation software that generates that simulate the dynamics of particles, even the body particles, blood, something blood, or the membranes, which contains lipids and protein. That's what I know. And to use the Newton equation to calculate the distance, the collision between the particles, so on. And generate this data as positions of this particle. And we try to visualize it, as you see.
Any other questions or comments?
We'll introduce, I think it might be the next slide actually. We showed the before and after picture, and you have the before, after, and context.
Yeah.
I don't think you need both the after and the context. I think you should pick one, although I'm not sure which one. Because I think the video displays the context very well.
I picked the third one.
Do you like it?
Yeah.
I like all three.
But actually,
This
if
one
I was,
is related to Omnia's question, because that third one is the lipids with the context.
Okay.
Yeah.
if you want to keep all three, I'd switch the two around. Because it seems like a smoother transition,
Mm-hmm.
coming from all particles, grey particles, no particles.
I agree.
Yeah, that's an option, yeah.
But I like the one with all the particles.
Maybe you should have the description or title under each image.
Mhm. Yeah. Thank you.
There's a chance, Nai, that you will meet this famous guy that wrote that simulation software that has 100,000 users. Is it? I can't remember what it's called now. VMD, maybe? No.
It's Gromax.
Gromax, maybe? Yeah. Anyways, you're going to have an audience with a lot of molecular dynamics simulation people in it that are interested. So.
Yeah, actually, they sent me an email. They make this body. Each group of people, they assign them to one group.
Mhm.
Yeah. I find myself with LV. LV.
Maybe you can forward it to me and
Yeah.
let's see. Yeah, that's quite a coincidence. You already know Elif. Good.